Okay, we're going to do a mole conversion problem, and we're going to go for broke. We're going for the whole thing. But first, let's really talk about the order in which we convert. Like, we know that normally we can convert, let's use something we understand, minutes. We can convert minutes to hours. And what does that convert to? That converts to days. Days converts to weeks. You get my drift here, right? Like, this is the order of conversion factors we have. And within that, we know that like there's 60 minutes in 1 hour, and that hours and days, that converts because there's 24 hours in 1 day, and days converts to weeks because there's 7 days in 1 week. And then we also know we can reverse this process. Like we could go backwards. We could go from weeks to days, right? I could like turn my arrows around and go from days to hours, right? I could go, and furthermore, you don't have to always convert all the way from minutes to weeks, right? Like if I wanted to know how many weeks were in 20 days, you could just go from days to weeks. You don't need to go through the whole process. You can just use parts. Okay, now let's translate that to chemistry. So we start with grams. Grams converts to moles. Moles converts to molecules. Molecules convert to atoms. All right? And again, you can go backwards in any of these. They go this train line. Imagine a train, and these are the tracks. You have to follow the tracks. You cannot jump. However, you can start wherever you want. You can go from moles to molecules. You can go from moles to molecules to atoms. You can go from atoms to molecules to moles to grams. You can go from atoms to molecules and never even touch the grams. You can kind of start and stop where you want as long as you stay on track. Now, to go from grams to moles, we have to use 1 mole and then the molar mass, right? Like the grams is probably gonna depend on what compound you're using. You have to add that up. Moles to molecules, 1 mole has 6.02 times 10 to the 23rd molecules. And molecules to atoms, 1 molecule has, it depends on the atoms. So for example, if we have a molecule of hydrochloric acid, that has 2 atoms. If we have a molecule of water, that has 3 atoms. If we have a molecule of, I need a really good one here, magnesium hydroxide, that has 1, 2, 3, doubled, 4, 5 atoms, right? So that depends on the compound. So there's 2 places in this that it depends on the compound. The molar mass, you have to add that up, and then the number of atoms, right? Like that's going to be dependent. Okay, so let's do a problem, like from top to bottom. And we'll start with a hard one, and then you can kind of work your way out of that. Do you need to take a screenshot of that? You should. There you go. Okay. All right, so let's say if there are 55 grams of, let's stick with magnesium hydroxide. Magnesium hydroxide. How many atoms are present? All right. So look what you're given. You're given grams. We're going to atoms. That means on the train we just talked about, we're going from grams, then grams go to moles, moles go to molecules, molecules go to atoms. We're going the whole way. We're taking the whole train line. So you're going to set this thing up. You're going to need a lot of spots. You always start with what you're given. So right here, we're going to start with 55 grams. Whatever you have in the top needs to go in the bottom, grams. Grams convert to moles. That means your top spot's going to have moles. All right, what do we know about this? We know that 1 mole has how many grams? We'll come back up here. What did we say about that? The grams depends on the molar mass. So we need to find the molar mass of magnesium hydroxide. Okay, it's 58.32. So you got that by adding up the weight of magnesium plus the weight of oxygen plus the weight of oxygen plus the weight of hydrogen plus the weight of hydrogen, because you've got that 2 after the bracket. It doubled. Okay, so now, do you see where we had grams? Grams. Now we've got moles, which means I need moles down here. So I'm going to put moles down here, and moles converts to molecules. 1 mole has 6.02 times 10 to the 23rd molecules. All day, every time, doesn't matter. Okay, now I've got molecules. Remember, I'm going to atoms, so I have to keep going. Now I've got molecules. So molecules is going to go on the bottom. Oops, black. Okay, molecules goes on the bottom. Molecules converts to atoms. Well, 1 molecule has how many atoms? In this particular compound, every molecule has an Mg, an OH, and an OH. It's got 2 OHs. So that is, count with me here, 1, 2, 3, 4, 5. 5 atoms. All right, so now I've reached atoms. I'm done. I've reached atoms. So I'm going to stop. So now here's my next move. You are going to multiply all the way across the top. All the way across the top. So you're going to multiply 55 times 1 times 6.02 times 10 to the 23rd. Put that in brackets or you will mess yourself up. Times 5. Hit equals. Get that number. Divide that by 58.32. Okay, so I'm going to put all of that in my calculator. I'm going to multiply across the top, and when I go 55 times bracket 6.02 times 10 to the 23rd bracket times 5 divided by 58.32, I get, I get 2.84 times 10 to the 24th. Now, be careful, depending on your calculator, it might have said 2.84 E24, or maybe it even said 2.84 24, or 2.84 space 24. All of this nonsense translates to times 10 to the 24th. So you have to write that down, even if that's not what your calculator says. Okay, so this is your final answer. And of course, we were looking for atoms. So we're going to finish this off by writing atoms. And that is all there is to it. Just clear as mud. Okay, bye.